Hello, everybody. Welcome to my YouTube video. So we were studying the inferential analysis since last week. This week also we will continue to understand better what inferential analysis we can opt for when we want to analyze our data. So these are the references. I took the contents and the explanation from these three courses, statistics in the quantitative research method in the University of Ottawa. So this is the references I took. So let's see this chart. Hypothesis test. That is about the inferential statistics. So you will put your null hypothesis and the alternative hypothesis when you wanted to proceed with your analysis. And then the result of the each analysis, you will decide. You will accept your alternative hypothesis, or you will accept that you are null hypothesis. So for that reason, we have to choose which inferential statistic can be most appropriate. So the first one is a cross-tab and then chi-square test. In fact, they are the same category of the test, but when you run the chi-square test, you can obtain the p-value, and then you will see more clearly. You can accept your alternative hypothesis. So the cross-tab, and then you can run the cross-tab, but when you run the chi-square, and then you will know the significance value, p-value, and then the association that is about the Kramer v or the gamma. So these are the value of your association, how much they are closely related. And then direction. So direction, that is about the if they are negatively or positively related. So the chi-square test, normally you need the nominal variable or ordinal variable. So the nominal is ordinal, they are categorical, they are not a continuous variable. So when you put the dependent, independent, and then that can be the nominal and then ordinal, and then you will calculate the by this test significance. So for instance, that example of the chi-square can be there is a relationship between the gender, so the female and the male, regarding to the social media platforms like Twitter, Facebook, and then Instagram, etc. So these dependent variable, we can say that is a social media platforms, and the independent variable is a gender, so the female or male, and then you can find how they are related. If they are significantly related, and then you will obtain the p-value is less than 0.05, and then you can say that those two gender and so there is a social media platform and the gender, they are significantly related. And then if there is association, you want to obtain, and then you will see that if the men use the more Twitter, and then women use the more Instagram, etc. So you can find the result from this test. So that is about also the direction, and then association, if they are very closely related, or that they are very weakly related. So we can find all these three things from the chi-square test. And the ANOVA test, that is about the difference of the means. So if there is a significantly different means between the more than two groups, you can run the ANOVA test. So the independent test can be the nominal, so the categorical variable, but they will be the three groups, more than two, not only the women and then men, but will be the another group. So for instance, independent variable can be the one example, can be the for instance, marital status, married, single, and then maybe they are not married, married, but they live together. So these three groups, how they are different in their means about their happiness. So the dependent variable should be the interval ratio, that is a continuous variable. So happiness is a continuous variable, and then the happiness, the means of happiness, how they are different by the three groups, like single, married, and then the staying together without marriage. So three groups. So in that case, you will opt for the ANOVA test. Correlation, you should have the dependent, independent variable. Both of them, they should be the continuous variable. So if we want the parametric test, that is satisfying the all assumption, and then you can take the continuous variable. If they are not the continuous variable, you can opt for the non-parametric test. That is a Spearman's law. So we can see that later. So in the parametric test, that should be the continuous variable, both of them. And then normally they don't have any distinction between the independent and dependent variable. So for instance, a correlation can be like the calorie, and that is a continuous variable. And then your exercise hours. So if there is a significant correlation between the calorie, how much calorie you take, and then the exercise hours. So you can find if there is a correlation between the two, or there is no correlation between the two. So we can find by significance p-value also. And then if there is a significant related, how? Direction means that it's positively, like if you have the more calories and then more working hours, that is a positive relationship. If you have the more calories and the less working hours, that is a negative relationship, negative direction. So we can find that how they are positively or negatively related. And then the regression. So that test produces the significance, direction, and association. So you can see that dependent and independent variable, they are clearly defined. So it's not like a correlation in regression test. You have the clearly defined independent variable, and then you have a clearly defined dependent variable. So for instance, like independent variable can be like your impulsive shopping, and then the dependent variable can be the amount of what you spent. So you can put independent variable is like your impulsivity of the shopping style, and then the purchase, the amount of your purchase. So in that case, we can find if they are significantly related, which means that your impulsive shopping that increased your the purchase amount, and then that will be the significant level we will see. And also direction means that if that is a high and then the other is a high, that is a positive relationship. If this is high, the other is low, and then that is negative relationship. And the association also we can find by the R square. That is how much amount accounted for this result. So that we will find also the association. So this is the about the chi-square test, ANOVA test, correlation, and then regression test. We have another chart here. This is a bit differently explained, but is very similar to the other one. So if we want the relationship between the two variables, so as I said, between the gender and the social media platform, between two categorical variables, if we want about the relationship, how they are related, and then you can conduct the chi-square test. So that is the one relationship test. So here correlation, you have the correlation test because that is when they are the continuous variable. They are not like a nominal and then ordinal variable. When they are the continuous variable, you can find the relationship between the two, that you can do the correlation. And then here when you have the you are so the when you have like ordinal variable, and then you cannot conduct with the Pearson correlation. You can conduct the Spearman's law because that is non-parametric test. And then also when your independent variable is the dichotomous, it's like only the two group, and then not the continuous variable, you can still run the point Bisserier correlation. And then if that is another dimension of the inferential statistic, in general is more advanced one. When you have the ANCOVA, not ANCOVA, sorry, when you have the like a covariate variable for the correlation test, that becomes the partial correlation, which means that dependent independent variable the relationship, and then you will delete the another influence of the one variable. So you can obtain the exactly how they are related, not account for another variable. So that is about the partial correlation. So we can run all of this, and then here nominal or nominal ordinal. You can run the chi-square test of association. So these are the inferential statistic. They are testing about the relationship and the correlation, and then chi-square test. And now you compare the two groups. That is about your two group, the mean of the two group, about the average of the two groups. So that is we can call that independent t-test. When your independent variable like which is a vector, and then if there is a two different groups, you can use the independent t-test. For instance, between the gender, the men and the women, and then about their grade, about the GPA you want to know, and then you will know by the independent test. The women have a more GPA than the men, and that is the independent test. And then you are comparing the two groups. When you compare the three groups, that becomes the ANOVA test. We already saw the ANOVA test, and then here ANCOVA means that you will still controlling the another variable's influence, and then that becomes the ANCOVA. But this one is more advanced statistics. And then compare the two paired observation. This one is still about the compare the means, but they are not the different groups. They are the same group as the dependent t-test. For instance, when you will calculate the when you will see the GPA of the one group in summer, and then you will wait for until winter, and in winter you will calculate about the mean of the one same group, and then you will compare the summer the GPA in the summer and the GPA in the winter, and then you can use the dependent t-test. And then one sample t-test, that is about you want to check your sample is proper compared to with the population. So that is a one sample t-test, and then you can use the one sample t-test in the many situations. But the t-test you can use the in the before proceeding with the independent dependent test with the one sample t-test also. And then is another also the more advanced in inferential statistics. Sometimes you will need the one sample t-test before proceeding with another t-test to check about your sample is proper to be treated. And then simple linear regression, that is about your independent variable is a scale variable, and then your dependent variable is about scale variable also. But sometimes your independent variable can be dichotomous. Like we call that dummy variables. So the men and women, or the white and black, or something like that. And then it's possible you can use the independent variable with the dichotomous, but dependent variable should be the continuous variable. So in the simple linear regression, you will find the how the independent variable predict about this result of the dependent variable. So for instance, that your dichotomous variable is like for instance that white and the black, and then your dependent variable can be like how people they dress, yeah. So how people go to the the party with the what color, and then you can say that white color dressed people, how many times they go to the party, and then black color, how many times they go to the party. You can predict when they are dressed white or black. You will know that. So this is about the for today, and then I will continue next time. Thank you so much. Bye.